Good day to everybody here present at our conference today. The title of our presentation is a low-cost, highly responsive capacitive control switch for lighting and motor control system. So these are authored by Efren D. Villaverde, Renato Armalio III, OPT Mahusay, Maureen Abuel, yourself, Miller P. Gonzalez, Alvin S. Alon, A.C. Lagman, and Ruel N. Delosa. For the introduction of our presentation, electrical switches are essential devices to control other electrical devices to operate them. It is highly reliable service or device that must be activated physically by moving, pressing, or releasing a button or related mechanism. However, some limiting factors in using mechanical switch include heat, vibration, arcing, and shocks due to deterioration. This dilemma of using traditional switches can be eliminated through capacitive touch switches. An alternative using electrical signal via touch, reducing mechanical connections. They are activated when a finger touches the surface of the switch. It works when a change in capacitance value is detected at the layered assembly of a printed circuit board or PCB and the touch surface. The development of capacitive touch switches leads to many applications in which those systems using electromechanical switches are replaced by touch mechanisms. It offers advantages over electromechanical switches in terms of its response time in energizing a load, is shorter, has a greater lifespan, and is straightforward to implement. This paper presents the development and applications of a low-cost yet highly responsive capacitive control switch to control different devices. And how about the system overview? So, lighting system application for dimmer using capacitive touch. As the figure shows, this system is composed of a wheel pad, connecting wires, Arduino board, PCB, and a lamp. For the operation of a dimmer, once the wheel pad is touched, the signal will be sent to the microcontroller and it will be processed based on the input. Lighting system application for three-way switch using capacitive touch. The figure shows the system is composed of sets of numbered pads, connecting wires, master and slave Arduino circuit boards, relay, and two lamps. This principle is similar to the operation of a three-way switch that is commonly found at households. Your part C, the motor control application for forward and reverse using capacitive touch, and how this works. The figure shows that the system is composed of touchpad, Arduino board, connecting wires, relay, and magnetic contactors for forward and reverse control. The schematics shows various components such as lamps, magnetic contactors for the operation of forward-reverse motor, the relays which serve as the switch for closing and opening of the main contacts. And how about the prototype's technical specifications? Letter A, we have touch board. The MPR121 is used as an interface between the capacitive keypad and the Arduino board with an inter-integrated circuit I2Z output. The Arduino board. The Arduino board is an economical and easy-to-use hardware that provides many applications in the field of control system. This board is built with ATmega328P microcontroller and provides many user interfaces. The forward-reverse starter. Reversing motor starter is composed of two magnetic contactors and one overload relay. To reverse the rotation of a three-phase motor, the two of three wires should be interchanged or simply interchange the connection of any of the two lines. The MPR121 capacitive touch sensor, a capacitive touch controller used an MPR121 board, which is driven by an I2C interface. There are 12 individual electrodes connected to the touchpad which are used as switch. The structure and organization. The system application for different controls. Wheel pads, three-way switch, and motor for forward-reverse control, were used in the prototype, as you can see on the figure from top to bottom. And how about the prototype's test results and evaluation? Voltage analysis and operational tests for dimmer switch. Table 1 or the table shows on the screen presents the different output voltages in each stage and its average output voltages. It shows that in every stage, when the voltage increases, the lamp increases its brightness, and when the voltage decreases, the lamp is dimming. The average value in each stage shows reliability and functionality of the touch switch. So you have here trials and the output voltages for each stage. So you can see on our rows and column the interpretation on our table 1. The voltage analysis and operational test for three-way switch. Again, the table 2 represents the number of successful and unsuccessful operating attempts of having the touch turn on in a simultaneous touching consists of 5 attempted touching per trial, as provided by our column on our table. Based on the data of the success rate in the table, the successful operating attempt over the number of attempted touch will have the result computed of success rate of 100%. It means that the prototype has shown its reliability as being derived from our table. And the voltage analysis and operational tests for motor control switch. Table 3 presents the number of successful and unsuccessful operating attempts of having the touch turn on in a simultaneous touching consists of 5 attempted touching per trials. So we have 5 trials on the table. Based on the data of the success rate in the table, the successful operating attempt over the number of attempted touch will have the result of success rate of 100%. It means that the prototype shows its reliability. And the breakpoint tests shows the table number 4. Table 4 presents the voltage and current using the digital and analog multimeter as an instrument used to measure the maximum tolerance. Our experiments verified that our capacitive switch design could endure 6 volt DC and the highest temperature of 87 degrees Celsius, better than 70% of the market's most popular commercial 12-channel switches. We have here on each row of our table, we have capacitive switches, relays, and relay for dimmer. And the results are configured on our column. The breakpoint tests. This state is the result of the incorporation of capacitive filter sensor. Regarding relay components, a threshold of 12 volt DC and 6 volt AC with corresponding peak temperatures of 115 degrees Celsius and 108 degrees Celsius were observed as represented or as presented on our table and figure. The benchmark comparisons to existing models. The Table 5 compares the costs of our capacitive switch prototypes to those of popular existing variants. To avoid a potential lawsuit, the brand names are not explicitly disclosed. Specifications with equal baselines are provided. Table 5 shows the comparative costing of existing models and prototypes. Benchmark comparisons to existing models. It shows that our prototypes is cheaper than other assemblies by 25% of the current market pricing for the specific components, although Model B exceeded the performance of our model. It is 38% more expensive with a negligible advantage of maximum temperature of 1 degree Celsius and a mean responsiveness difference of only 0.023 seconds. The tables provided us the result of our costing in US dollars, specification, and its responsiveness. Conclusions and recommendations. The capacity of the capacitive touch control switch was determined based on the current rating of the relays used to close and open the circuit, the magnetic contactor used to control the motors, and on the number of lamps to be controlled in different locations. In the evaluation and testing of the device, the results show a 100% success rate in the functionality and reliability of the touch switch and responsiveness of 0.05 seconds, comparable to commercially available 12-channel capacitive switches. Moreover, our prototype is cheaper by 25% compared with commercially available assemblies. For future works, the researcher recommends a multi-touch application to give additional function. Wireless technology like Bluetooth and wireless fidelity can also be applied in capacitive touch switching from remote location. Thank you very much for listening.